It's asking us, now read it carefully, it's asking us for the fraction of the volume taken up, occupied by the ideal gas molecule. It doesn't tell us what the ideal gas is, it just tells us it's an ideal gas. Now, when you see that, of course, we won't be using it for this question, but if ever tells you that's an ideal gas, we know that the equation PV equals nRT holds up. But for this question, we probably won't need it. So, 1 mole, we know Avogadro's number is 6.02 times 10 to the 23. As well, we know that the volume total is 22 over 4 liters, which we also write as 22.4 over 1,000 meters cubed. As well, we know that the volume of each particle is 1 angstrom, which is equal to 10 to the negative 10 meters cubed. Sorry, meters, because it's the radius of each particle. Right, so from here, it's a simple question, but you have to be careful with what it's asking for. Immediately, people would go for what is the total volume, but of course, it doesn't want that. It wants the fraction of the volume occupied. Now, what that means is we want to know the volume of the particles over the total volume, right? So we know that to be the total volume is the volume of the container. So we'll call this volume container. How about that? Over the volume of all particles, right? So that would be the volume of course, total particles. So here would be volume of every individual molecule. Make sure you understand that. This is the total volume of every molecule present, and this is the total volume it can take up. Again, we're denoting total volume of the canister as Vc, and the total volume of each individual molecule is Vp, and we'll multiply that by the number of molecules you have, which is Na, or Avogadro's number. Right? So what this actually means to us conceptually is if you have a container filled with, let's say, kind of container like this. Of course, it's filled with molecules, but of course, these molecules are so small that they doesn't take up 100% of the space. So once it's defined as if we were to condense this entire lid on the top, press it down, what would be the new total volume? Right? What's the actual volume that these particles take up? Right. So we're trying to figure that out. So that would be, of course, simply the total number of molecules times each volume. So if you wanted to know what's total volume people take up in a stadium, then of course you'd multiply the number of people times the volume of each person over the volume of the stadium, right? But here it's particles. So this becomes something. The volume of each particle is 4 over 3 pi r cubed times, of course, Avogadro's number. And of course, the volume total is, of course, 22.4 liters. And of course, always remember to convert all units, no matter what, to SI. So always convert units to SI. And all that means is you always should convert length to meters, weight to kilograms, also, temperature to Kelvin, and there's a bunch more. But if you always have just an SI, then things will always cancel out. If you don't, you need to do something called unit analysis and make sure that all your units cancel out. But if you trust your equations and you have converted all your numbers to SI, then you can trust in your answer. But yeah, this is simply your final equation for this question.